Good afternoon, students. In the previous class, we have discussed one problem on Hartnell governor, and after that, we discussed what is the meaning of vibration, what are the main causes of vibration, what are the reasons for the vibration. So after that, we gone through the various types of vibration. So in that we have discussed 6 types of vibration, and then we have discussed some of the basic definitions which are associated with vibration. In today's class, let us first understand what is a simple harmonic motion. So first understand what is simple harmonic motion. So I am going to draw the figure for this so that we can understand it easily. So already these things we have discussed during So first understand what is meaning of simple harmonic motion. So simple harmonic motion means the motion of a body to and fro about a fixed point is called as simple harmonic motion. So once again I will repeat what is the simple harmonic motion. The motion of a body to and fro about a fixed point is called as simple harmonic motion. Say for example, if I consider the simple pendulum, so the initially the simple pendulum, its rest condition, in its rest condition the ball will be here, so it is fixed here, the ball will be here. So if I give an excitation to this, or if I give a force to this, then what will happen? So it will move to this position, then come back to this position, move to once again this position, then come back to this position. So as the time increases, the motion will be repeated and finally come back to its original position. So simple harmonic motion means the to and fro motion, the to and fro motion about its fixed point is called as the simple harmonic motion. So here the motion is always periodic. The motion is periodic and its acceleration is always directed towards the mean position. So here the motion is periodic. So it is going to this position and once again coming back to this position, once again going to this position, coming back to this position after several interval of time, after a certain period of time. So it is coming back to its mean position. So here the motion is periodic and the acceleration is always directed towards its mean position and is always proportional to the distance from the mean position. The acceleration is always proportional to its distance from the mean position. Very, very important. So what is simple harmonic motion? The simple harmonic motion means to and fro, the motion of a body to and fro about a fixed point is called as simple harmonic motion. The motion is periodic here and its acceleration is always directed towards its mean position. The acceleration is always directed towards its mean position, and one more important thing, the acceleration is always proportional to its distance from the mean position. The motion of a simple pendulum The example for this is the motion of a simple pendulum, which is shown here. Let us consider a body having simple harmonic motion is given by a body having simple harmonic motion, or in short it will be called as SHM also, simple harmonic motion. A body having simple harmonic motion is given by the equation which we have seen in the previous class. X is equal to A into sine of omega t, where x is displacement, So if I differentiate the displacement, I am going to get velocity, that is nothing but x dot, and it is given by A into omega into cos of omega t. So if I differentiate velocity, I am going to get the acceleration, and it is given by x double dot. So x is displacement, x dot is velocity, and x double dot is acceleration. So once again, if I differentiate this velocity, I am going to get minus of A into omega square into sine of omega t. So therefore x double dot is equal to, we know that A into sine omega t is nothing but x. So substitute the value for that, that is A sine omega t. So it will be minus omega square into x. So x double dot, that is the acceleration, is given by minus of omega square into x, where x is nothing but displacement, x dot is velocity, and x double dot is nothing but it is acceleration. So once again I will discuss what is a simple harmonic motion. The motion of a body to and fro about a fixed point is called as simple harmonic motion. The motion is always periodic, and its acceleration is always directed towards the mean position, and this acceleration is proportional to its distance from the mean position. Say for example, simple pendulum, if I give the excitation to this pendulum, so it starts moving to and fro about its mean position. A body having simple harmonic motion is given by the equation x is equal to A into sine omega t. So if I differentiate, so in this x means displacement, so if I differentiate the displacement, I am going to get velocity. So differentiation of A sine omega t is A into omega cos omega t, and if I differentiate velocity, I am going to get acceleration. So it is represented by x double dot. So differentiating velocity, I am going to get minus of A into omega square into sine omega t. So we know that A into sine omega t is nothing but x. So substitute A into sine omega t as x. So I am going to get acceleration as x double dot is equal to minus of omega square into x, where x is displacement, x dot is velocity, and x double dot is acceleration. So with this knowledge, let us go for the next topic, that is parts of a vibrating system. The next topic is parts of a vibrating system. So let us discuss the next topic, that is parts of a vibrating system. A vibratory system basically consists of three elements. A vibratory system basically consists of three elements. First one is the spring, which is denoted by spring stiffness K. Second one is the damper, which is denoted by C. And the third one is the mass, and which is denoted by M. In a vibrating body, there is an exchange of energy from one form to another form. In a vibratory body, there is an exchange of energy from one form to another form. The energy is stored in the mass. The energy is stored in the mass in the form of kinetic energy, and it is given by half into m into x dot square. So this is very, very important. The energy is stored in the mass in the form of kinetic energy, and it is given by the energy is stored in the mass in the form of kinetic energy, and it is given by the equation. So you know what is the equation for kinetic energy. So the equation for kinetic energy is half into m v square. So that is our equation for kinetic energy. But here we are not going to represent it as v. So here half into m into x dot square. We are going to represent it as x dot square, because we have seen in previous concept of simple harmonic motion and in yesterday's class, x is represented as displacement, v velocity is represented as x dot, and acceleration is represented as x double dot. So in the previous class and in today's class, we have seen that displacement is represented as x, velocity is represented as x dot, and acceleration is represented as x double dot. So the equation for kinetic energy, we know that half into m into v square. So velocity means it is represented by x dot. So I am going to represent it as half into m into x dot square. So this is the energy is stored in the form of kinetic energy in case of mass. Similarly, in case of spring, the energy is stored in the form of potential energy. We have seen the energy is stored in the mass in the form of kinetic energy, and it is given by half mv square. Similarly, the energy is stored in the spring in the form of potential energy, and it is given by half into k into x square. Similarly, the energy is stored in the spring. The energy is stored in the spring in the form of potential energy, and it is given by half into k into x square. Half into k into x square. So these two things very, very important, you have to remember. So basically a vibratory system consists of three components: mass m, spring with a stiffness of k, and damper represented by c. The energy is stored in the mass in the form of kinetic energy, and kinetic energy is given by half into m into v square. So velocity we are going to represent it as x dot, so it is half into m into x dot square. Similarly, in the spring, the energy is stored in the form of potential energy, and it is given by half into k into x square. In the damper, the energy is dissipated. In the damper, the energy is dissipated in the form of heat energy. So here, in the mass, the energy is stored in the mass in the form of kinetic energy. In the spring, it is the potential energy. But in case of damper, the energy is dissipated in the form of the heat energy. The energy enters the system with the application of external force. So always the energy enters the system with the application of the external force only, and this external force we are going to call it as excitation. So excitation means it is nothing but it is the external force. You have to remember while solving the problems, so we are going to make use of the term called excitation. So excitation means external force. So energy always enters the system with the help of excitation or with the help of external energy only. This excitation disturbs the mass from its mean position, and because of this mass moves up and down from its mean position. So we have understood that the energy enters the system with the help of external force or excitation. So this excitation disturbs this mass, and because of this disturbance first, the parts of vibrating systems are three. One is mass, second one is spring, third one is damper. In the mass, the energy is stored in the form of kinetic energy, and it is given by half mv square, that is nothing but half into m into x dot square. And in the spring, the energy is stored in the form of potential energy, and it is given by half into k into x square. In the damper, the energy is dissipated in the form of heat energy. So always the energy enters the system with the help of external force. That external force is known as excitation. So because of that excitation or the external force, the same time the damper opposes the motion of the mass with a damping force of C into x dot, with a damping force of C into x dot. So it means for any of the system, when you give an external excitation or when you give an external force or when a force acts on any of the system, so there will be an resistance force also. So the damper does the same thing. The damper opposes the motion of the mass with a force of C into x dot. So please understand what is the use of damper. The damper is used to oppose the motion of the mass, and it opposes the motion of the mass with the force of C into x dot. Thus some energy is dissipated in each cycle of vibration due to damping. Thus the free vibrations die out and system remains at its static equilibrium, and hence the equation of motion for such a vibratory system is given by the equation of motion is given by mx double dot plus cx dot plus kx is equal to 0, and this equation of motion holds good for spring mass damper system. Spring mass damper system. So mx double dot plus cx dot plus kx is equal to 0, and this is the equation of the motion for vibratory system, and this application holds good for spring mass damper is x dot and acceleration as x double dot. So this v is replaced by x dot. So the equation for kinetic energy becomes half into m into x dot square. Similarly, the energy is stored in the spring in the form of potential energy, and it is given by the equation half into k into x square. So the system remains in equilibrium, and it is disturbed only when an external force is applied, and that external force is called as excitation. So because of the external force or excitation, the mass is disturbed from its mean position and it starts vibrating in the upward and downward motion. So for this motion of the mass, there will be a resistance, or this damper opposes the motion of the mass with a force of C into x dot. So in this process, the kinetic energy is converted into potential energy, and potential energy is converted into kinetic energy. The equation of motion for such a system is given by mx double dot plus cx dot plus kx is equal to 0. So this equation holds good only for spring mass and damper system, because mx double dot is the inertia force because of mass, cx dot is the damping force because of the damper, and kx is the spring force because of the spring. If the system consists of only spring and mass, then the equation of motion holds good as mx double dot plus kx is equal to 0. So this is the concept, basic concept. So this equation of motion we are going to make use in while solving the problems. So please remember these equations of motion. So if you don't know the equation of motion, then it is not possible to solve a single problem. So I request all of you to understand these equations of motion properly, so that while solving the problems, we will be not having any questions or there will be any doubts, so that you can solve the problems very easily. So let us go for the next concept in this chapter. So that is addition of harmonic motion. Addition of harmonic motion. So before going that, let us understand what is phase difference. Let us understand. Actually, I would have discussed in previous class only, while discussing some basic definitions of vibration. So anyway, let us discuss now what is phase difference. So what is phase difference? Suppose there are two vectors. Say vector 1 as x1 and vector 2 as x2. Suppose if there are two vectors x1 and x2 having frequencies omega, the frequency of x1 is also omega and the frequency of x2 is also omega, or you can call it as omega 1 or omega 2, or you can say only omega, and the unit for omega is radian per second. The vibrating motion can be represented as, for such system, the vibrating motion can be expressed as x1 is equal to a1 into sine of omega t, and x2 is equal to a2 into bracket into sine of omega t plus phi. x1 is equal to a into sine of omega t, and x2 is equal to a2 into sine of omega t plus phi. In the equation of x2 there is a term called phi. That term phi is known as the phase difference. That term phi is known as the phase difference. Consider there are two vectors, one is x1 and another one is x2, having a frequencies of omega, or you can say omega 1 or omega 2, or you can understand both are having same frequencies omega. Then the vibrating motions for system is represented by x1 is equal to a1 into sine omega t, and x2 is equal to a2 into sine of omega t plus phi. So this phi is known as the phase difference. This phi is known as the phase difference. So this is the basic definition of phase difference. With all this knowledge, let us go for the next concept. The next concept is addition of harmonic motion. The next topic is addition of harmonic motion. The next topic is addition of harmonic motion. So when we add two harmonic motions, of same frequency, once again I will repeat, when we add two harmonic motions of same frequency, we are going to get the resultant as also harmonic. We are going to get resultant as also harmonic. If we add two harmonic motions of same frequency, so whatever the resultant we are going to get, so that is also a harmonic. So let us have two harmonic motions of amplitude A1 and A2. Let us have two harmonic motions of amplitude A1 and A2 having same frequency of omega and having a phase difference of phi. Let us have two harmonic motions. Let us consider two harmonic motions with amplitude A1 and A2 having frequencies of omega and a phase difference of phi. So let us write the equations. So let x1 is equal to a1 into sine of omega t. So I will call this as equation number 1. x1 is equal to a1 into sine of omega t, and another one is x2, so which is equal to a2 into sine of omega t plus phi, and I will call this as equation number 2. So I have two vectors x1 and x2 having amplitudes a1 and a2 having frequency of omega and a phase difference of phi. So first is represented by x1 is equal to a1 into sine of omega t, and second one x2 as a2 into sine of omega t plus phi, where phi is the phase difference, a1 and a2 are the amplitudes. The resultant motion can be obtained by adding the above equations. The resultant motion is obtained by adding the above equations. The resultant motion is obtained by adding the above equation. So that is the resultant motion, let be it as x is equal to x1 plus x2, where x is the resultant motion and x1 and x2 are already known. So substitute the values of x1 and x2 in this equation. So this will be x is equal to, what is the value for x1? So it is a1 into sine of omega t plus x2 is a2 into sine of omega t plus phi. So what I have done is, in the equation of resultant motion, that is x is equal to x1 plus x2, I have substituted the value of x1 and x2. The value of x1 is a1 into sine of omega t, and the value of x2 is a2 into sine of omega t plus phi. So x is equal to a1 into sine omega t as x1 value, and a2 into sine of omega t plus phi as the value of x2 I have substituted in the equation. So therefore x is equal to a1 into sine of omega t plus a2 into the bracket sine of omega t plus phi. I have to extend the equation of sine of omega t plus phi. So I will get sine of omega t into cos phi plus cos of omega t into sine of phi. So what I have done here, I use the basic equation of the trigonometry, that is the sine of a plus b. We know the equation for sine of a plus b, and it is given by sine a into cos b plus cos a into sine b. So that is the basic equation of sine of a plus b. So in place of a we have omega t, and in place of b we have phi. So what is the equation? Sine a into cos b. So sine of omega t into cos phi plus cos a into sine b plus cos of omega t into sine of phi. So therefore, I will continue here. Therefore x is equal to sine of omega t into bracket a1 plus a2 cos phi plus a2 into cos omega t into sine phi. So I will call this as equation number 3. So what I have done here. So if I expand this bracket, so what I will get, x is equal to a1 plus a1 into sine omega t plus a2 into sine omega t into cos phi plus a2 into cos omega t into sine phi. So what I have done is, I have taken sine omega t as a common. The remaining term will be a1 plus a2 into cos phi. I have taken it in bracket. Then the remaining term, what is the remaining term? a2 into cos omega t into sine phi. I have kept it as it is. Let us assume, or assuming a1 plus a2 cos phi is equal to a cos theta. Assuming a1 plus a2 cos phi is equal to cos theta, and a2 sin phi is equal to a into sin theta. Let us assume that a1 plus a2 cos phi is equal to a cos theta, and a2 sin phi is equal to a into sin theta. So therefore I will call this as equation number A. Therefore, substituting the values of a1 plus a2 cos phi, substituting the equation A in equation 3, substituting the value of a1 plus a2 cos phi and a2 sin phi, that is nothing but equation A, into equation number 3. So what we are going to get? So we are going to get x is equal to a1 plus a2 cos phi is what? A cos theta. So the remaining term is a into sin omega t into cos theta plus a sin theta, because a2 sin phi is a sin theta, into cos of omega t, So how I can write this? I can write it as A into sine of omega t into cos theta plus A into cos omega t into sine theta. So I have taken cos theta first and then I have written sine theta. So this is nothing but x is equal to A into sine of omega t plus phi. This is nothing but A into sine of omega t plus phi. Sorry, not phi, it is theta. Sine of omega t plus theta. So A outside in these two equations, A sine omega t plus cos theta plus A cos omega t sin theta, I have taken A as outside and in bracket I have written sine omega t into cos theta plus cos omega t into sin theta. So this is nothing but sin A into cos B plus cos A into sin B. So that is nothing but once again sine of A plus B. So that becomes x is equal to A into sine of omega t plus theta. The equation, this equation of x, that is nothing but x is equal to A into sine of omega t into x is equal to A into sine of omega t plus theta, shows that the resultant displacement is also simple harmonic motion of amplitude A and phase theta. So in the beginning we have seen two equations, that is x1 is equal to A into sine omega t. There are two harmonic motions, one is x1 is equal to A1 into sine omega t and another one is x2 is equal to A2 into sine of omega t plus phi. So we have understood that the addition of two harmonic motion will also result into a harmonic motion only. So how we have got? So we have x1 is equal to A1 into sine omega t and x2 is equal to A2 into sine of omega t plus phi. So if we want to get the resultant, so how to get the resultant? Resultant is nothing but the addition of these two vectors. So x is equal to x1 plus x2. So what is the value for x1? The value for x1 is A1 into sine omega t here plus x2. What is the value of x2? A2 into sine of omega t plus phi. So then what I have done, x is equal to A1 into sine omega t, I have kept it as it is. A2 I have kept as it is. Then the sine of omega t plus phi, I have considered it as a sine of A plus B. From our trigonometry, we know that sine of A plus B is nothing but sine A into cos B plus cos A into sine B. So in place of A we have omega t and in place of B we have phi. So if I expand the equation of sine of omega t plus phi as sine of A plus B as sine A into cos B plus cos A into sine B, I am going to get sine of omega t into cos phi plus cos of omega t into sine phi. So then what I have done is, I have kept A1 sine omega t as it is, then multiply this A2 with all the terms inside the bracket. So it becomes A1 sine omega t plus A2 into sine omega t into cos phi plus A2 into cos omega t into sine phi. So in that I have taken sine omega t as common. The remaining term will be x is equal to sine omega t as the common, A1 plus A2 cos phi plus A2 into cos omega t into sine phi. I will call this as equation number 3. Let us assume A1 plus A2 cos phi is equal to A cos theta for simplification and A2 sin phi is equal to A sin theta. So substitute the values of A1 plus A2 cos phi and A2 sin phi into equation number 3. So what we are going to get, x is equal to A into sin omega t into cos theta plus A sin theta into cos omega t. So next step is equal to A sin omega t into cos theta I have kept as it is plus A as it is. Cos omega t first I have written, then I have written sin of theta. So in this I have taken A as common, then sin of omega t into cos theta plus cos of omega t into sin theta is nothing but sin of A plus B. Sin A into cos B plus cos A into sin B, that becomes sin of A plus B. So I have written x as A into sin of omega t plus theta. So after adding two harmonic motions, if I find out my resultant is also a harmonic one with an amplitude of A and phase difference of theta. So after adding two harmonic motions, the resultant equation will also be a harmonic motion with an amplitude of A theta. So we have got the resultant harmonic motion, that is x is equal to a into sine of omega t plus theta. But we need to find out what is the value of a. So to get the value of a, so whatever the equations we have chosen, a1 plus a2 cos phi is equal to a cos theta and a2 sin phi is equal to a sin theta. So squaring and adding the equations, these two equations, that is I call this as equation number 4. Squaring and adding the equations, squaring and adding equation 4. So what we are going to get, a square into bracket cos square theta plus sin square theta, a square into bracket cos square theta plus sin square theta, which is equal to a1 plus a2 cos phi whole square plus a2 square sin square phi. So squaring and adding both the equations, so this is a square into cos square theta plus sin square theta, a square I have taken common, is equal to a1 plus a2 cos phi whole square plus a2 square into sin square phi. So we know that cos square theta plus sin square theta is always equal to 1. From our basics of trigonometry, we know that cos square theta plus sin square theta is equal to 1. So this term becomes 1, then the remaining term will be only a square. So a square is equal to, so this is a1 plus a2 cos phi whole square, that is nothing but a plus b whole square. So a plus b whole square, what is the formula? A square plus b square plus 2ab is the formula. Like that we need to expand it. So a square is equal to a1 square plus b square, a2 square cos square phi plus 2ab. So that is nothing but 2 into a1 into a2 into cos phi plus a2 square sin square phi plus a2 square into sin square phi. So for LHS side it is a square into cos square theta plus sin square theta. From the basics of trigonometry we know that cos square theta plus sin square theta or sin square theta plus cos square theta will be always equal to 1. So substitute the value of cos square theta plus sin square theta, this becomes 1. So 1 into a square becomes a square. So similarly in the RHS side it is a1 plus a2 cos phi whole square plus a2 square sin square phi. So it is like a plus b whole square. So if I expand a plus b whole square, what is the formula? A square plus b square plus 2ab. So like that I need to expand a1 plus a2 cos phi whole square. So in place of a we have a1, in place of b we have a2 cos phi. So if I expand, what I am going to get? In the LHS it is a square. So a1 square plus a2 square cos square phi plus 2 into a1 into a2 cos phi plus a2 square sin square phi. So therefore a square is equal to a1 square plus we have a2 square cos square phi plus a2 square sin square phi plus 2 into a1 into a2 into cos phi. So what I have done is a square, keeping it as it is, a1 square as it is, a2 square cos square phi as it is. So first I have written this. After this I have written a2 square sin square phi plus 2a1 a2 into cos phi. The change is, first I have written a2 square sin square phi, then I have written 2 into a1 into a2 into cos phi. So therefore a square is equal to a1 square plus a2 square into bracket cos square phi plus sin square phi plus 2 into a1 into a2 cos phi. So I have taken a2 square outside and inside the bracket I have written it as cos square phi plus sin square phi. So once again, cos square phi plus sin square phi, what is the value? The value of cos square phi plus sin square phi is 1. So a square is equal to a1 square plus a2 square into 1 is nothing but a2 square plus 2 into a1 into a2 into cos phi. A square is equal to a1 square plus a2 square plus 2 into a1 into a2 into cos phi. So therefore I can get the value for a. So therefore the value of a will be under root of a1 square plus a2 square plus 2 into a1 into a2 into cos phi. So this is the value for a, or this can also be written as a is equal to 1 by 2, or sorry, a1 square